In this video, we'll talk about models for fractions and various visual representations. In grades K through 8, there are three primary models that we tend to use. We have the area model, the linear model, and the discrete set model. Let's talk about the area model first. With the area model, we tend to pick a two-dimensional shape and then break it up or partition it into subregions that all have the same area. Circles are really common. I find that I have a hard time drawing a circle, like on a whiteboard or something. The iPad here will do a nice job of fixing my circle for me, so I can easily draw the circle and then, cut it in half and have two halves. But freehand, my circles don't tend to be so nice. They're a little bit harder to work with. I tend to prefer rectangles for my area model. So the reason for this is particularly when I'm drawing, freehand on a whiteboard, one thing that I can do is I can draw three sides of the rectangle and then just estimate my equal parts and fill in the end as needed. It's hard to do something like fifths or sevenths in a circle, but those can make really nice examples. So here I'm going to freehand draw. It's not perfect. I'll try to make it a little better than that. I won't use the tools of the iPad to straighten it out for me. And here if I go 1, 2, 3, 4, 5, 6, 7, I can come in here and just make that the end of my model. Each of the strips is worth 1/7 of the whole here. There are some great manipulatives, so physical objects that we can use rather than drawings. So let's look at one really common one, the pattern block. These are pattern blocks. They're really neat because they're standardized regardless of what brand you buy. One side of a pattern block is 1 inch long. So they all measure and so they can line up. You can see I have different brands here. I have plastic ones, wood ones, and they come in slightly different colors, but you always have a yellow hexagon, 6 sides right there. 2 red trapezoids will fit onto a yellow hexagon. 3 a blue rhombus. Here, rhombus has 4 equal sides, opposite sides parallel. 3 will fit onto a yellow hexagon. And then the green, you can see sometimes they come in different shades here, but each green triangle, again, are a side. One side is 1 inch here. One side is 1 inch. So all the sides are the same length. They're all 1 inch sides, and you can fit 6 of the green triangles onto the yellow hexagon. And we have these 2 extra shapes, the tan rhombus and the orange square, which can help with making designs. Let's practice with some virtual pattern blocks. Let's decide that our reference hole is the red trapezoid. We can divide it or partition it into 3 equal parts by covering it with 3 green triangles. If we wanted to show 2/3 of a red trapezoid, we note that each green triangle is 1/3 of a red trapezoid. So 1/3 and a second third, we have 2 parts, each worth 1/3 of a trapezoid. So there are 2 green triangles represents 2/3 of a red trapezoid. Next, let's talk about the linear model. Linear models use lines. They're one-dimensional. And here we would mark 1. That's going to be our reference hole, and then we can subdivide it into as many different parts as we want. So we could have half, we could have fourths, we could have eighths, And then we just reproduce that. We iterate, so it's like a ruler in inches or centimeters or something. We would have the second, we would continue with our eighths. And that would be our second unit right there. Each space in number lines, we're counting the spaces here. The space between 0 and 1 is 1 unit. And the space here is 1/8 of a unit. So every one of these spaces is 1/8. And then we can count one space worth an eighth. And then we have two spaces, each worth an eighth. Three spaces, each worth an eighth. Four spaces, each worth an eighth, and so on. It's important here to try to have our spaces to be the same size. We're trying to have equally sized parts in here. A good manipulative to use that leads to the linear model are Cuisenaire rods. Cuisenaire rods are really great with fractions. When we look down on them, they're rectangles, so they're actually have this two-dimensional surface, but we can trace the edge and make the line to turn it into that linear. Each unit is 1 centimeter long, so you can see that two white rods are the same length as a red rod. So this is 2 centimeters long, and we go all the way up to 10 here with the orange one. So we can make a whole variety of different fractions. Here we can notice, let's move these aside, and let's make our whole, our unit whole, the purple one. And I can notice that 2 red rods, I can make a train of 2 red rods, and it's the same length as the purple one. So I can use this to develop my linear models. So let's draw a line, and I'm going to start this purple one here, and I'm going to mark either end. So this would mark the end of one rod here, so we'll start at 0, and then I can iterate. I can do a second one here. Now I have 2, and I could keep going. Then, because I can partition my purple rod into 2 equal parts, that gives me the denominator. So I can mark here, there's my 2 equal parts, and I can mark the end of 1. And this is 1 part, and the 2 tells me that my whole was broken into 2 equal parts. So this is half of a purple rod, and then I have a second one here. These work nicely with improper fractions. So if I were to look at 3 halves, 3 parts, each worth 1/2 of a purple rod, there's 3 halves, and I can look, what is that equivalent to? That's 1.5 purple rods. And so here, right, here's my 1.5, or I could call it 3 halves because it's 3 rods, each worth half of a purple. And now I have this really nice number line that I can work on my fractions with. Finally, let's talk about the discrete set model. In the discrete set model, we're looking at collections of objects. So instead of the area model, the 2D objects, or the linear model, the line, now we're looking at sets or collections of objects. In this example down here, I'm imagining marbles. So I could have marbles of 2 sizes, a large or a small marble, and marbles in 2 different colors, red or blue. So let's look at these as 2 examples. And our reference whole is the collection of 6 marbles. So I can take my collection and I can subdivide it into 2 parts. I could think about the blue part versus the red part. And then I could say half of the marbles are blue, or similarly, half of the marbles are red. I could take the same set of marbles and I could divide them in another way. Here I could think about the large marbles versus the small marbles. But as I subdivide, I want to have equal size groups. Here when I'm talking about size, really what I'm talking about is the count. So I'm going to have 2 marbles per group. So I've broken it into 3 sets of 2 marbles each. And now I could say that 2/3 of the marbles are large. So I have my 3 groups That gives me my denominator. And then when I'm looking at the large ones, I could say that 2/3 of the marbles are large. We could use either pattern blocks or Cuisenaire rods for our discrete set models, but let's take a look at another manipulative. Let's use 2-color counting chips for our set. Let's make a set of 12 counters. Then I can switch the color to show different fractions. So I'm thinking of these as 12 individual objects, and if I asked you to show me 3/4 of the set, well, I can look and see that I have 4 columns. So 3/4 means that I want to break into 4 equal groups. So each column, each of the 4 columns would be a single group, and then I want to shade in 3 of them or flip 3 of them. So there's our first fourth, our second fourth, our third fourth. So now 3 of the 4 columns, my columns are my groups, are red. I've shown 3/4 of the counters are red.